We're going to refresh our memory on some polynomials today, starting with some properties of exponents for monomials. So say that you have two terms with the same base being multiplied together. You can add their exponents. If you have something with an exponent raised to another exponent, you would multiply those exponents together. Anything raised to the 0 power is equal to 1, whether it's something super crazy like that or just x to the 0, those are 1. And about that whole why is something raised to the 0 power equal to 1, let's look at it first as kind of a pattern here. So if I look at these powers of 3, we'll say I'm not sure what 3 to the 0 should be. I'm going to go ahead and add in a 3 to the 3rd there at 27 as well. Well, if you kind of look at what's happening, I'm multiplying by 3 each time in this pattern because I'm increasing the number of factors of 3. So in order to make this pattern work, 3 to the 0 would have to be 1, because to get to follow this pattern, you'd multiply 1/3 by 3, which puts you at 1. You could also look at it using another property, where if you have 3 squared over itself, well, 2 minus 2 is 0, so 3 to the power has to be equal to 1, because 3 squared divided by itself is equal to 1 too. Let's simplify some expressions. So if you have these being multiplied, you have 3 factors of x and then 9 more. So add them together, you get a total of 12 factors of x, x to the 12th. On b, when you're multiplying, I want to go, okay, I have 1 factor of x and then 3 more. Add those to give it a total factor of 4 factors of x. And then 13 factors of y. Anything to the 0 power we said is 1. So if you multiply x to the 4th times y to the 13th times 1, it's just x to the 4th times y to the 13th. On c, I'm raising that entire expression to the 2nd power, both the numerator and the denominator. So I could use my power of a power property and go, okay, I need to multiply my exponents by 2 that I have. So if I do that multiplication of every exponent by 2 on my term on the inside, I get 9t to the 8th. And then divided by r to the 4th q squared. Don't forget to raise your 3 to the 2nd power as well. You could write this out twice because you're squaring it, and that's really what you're doing here, and see that you end up with the exact same thing if you multiply. If we look at some student work here, they made a couple of mistakes, like on part A, it was -2 inside that quantity as well, and they didn't take that to the 3rd power. It should have been -8. So they understood that they needed to multiply their exponents on their variables times 3, but they forgot that they needed to also raise their coefficient to that 3rd power as well. So they had it most of the way. If you look at B, this is a really common one that I see. So you can't multiply an exponent in if there are 2 terms. In order for that power of a power property to work, it has to be a single term inside there, something like 2x squared, not 2 plus x to the 2nd. So instead, what we need to do, if we have a binomial where there are multiple terms or anything with multiple terms, is we actually need to go ahead and write that out and multiply it times itself, because we're going to have to use the distributive property and multiply x times x, and then x times 2, 2 times x, and then 2 times 2 to get everything multiplied by everything else. So be really careful with that one. So let's look at what a polynomial is. So a polynomial is an expression that has only positive whole number exponents, and it can't have variables in the denominator. There are different types of polynomials with different names. A monomial has 1 term, binomial has 2, trinomial has 3, and polynomials also have what's called a degree, which is related to the exponent on your variable. Every term in a polynomial has its own degree, so say I have x squared plus 3y. X squared has a degree of 2 because my variable is being raised to the 2nd power. 3y has a degree of 1 because that's y to the 1st. I'm going to throw in another term here too. Let's say we also have plus 4z squared y. The degree of that term is the sum of the exponents on my variables in that term. So that's degree 3, 2 plus 1. for the whole entire polynomial, which is a trinomial, because there's 3 terms, it has degree 3 because that's the largest of any of those degrees on the individual terms. So we're going to look at these, determine if they're polynomials, and classify them by degree and number of terms. On A, yes, that's a polynomial because it has positive whole number exponent. It's just x to the first. My coefficient is square root of 3, but that's fine. And it's degree 1 because it is x to the first power. On B, it is again a polynomial because it has all positive whole number exponents. It's a trinomial because there are 3 terms. And if I'm thinking about my degree of each term, that one is just a constant. It has degree 0. And then I have terms of degree 2 and 4. So overall, the largest one is 4, so it's a degree 4 trinomial. On C, it's not a polynomial. It has both a fractional exponent and a variable in the denominator. D is a polynomial. Specifically, if you look at it, it has 2 terms, so it's a binomial. And if you look at their degree, my second term is degree 2, because the sum of the variables exponents in that single term is 2. And the first term is degree 5, so overall it's 5. Let me also do a quick reminder of some vocab related to degree of polynomials, because I'm going to use them in the next example. So polynomials can be classified by degree as well as number of terms. If it's degree 0, it's called a constant. That's just plain old number like 4, 6. Degree 1, like your variable to the first, is linear. Degree 2 is quadratic, like 3x squared. And degree 3 is cubic, something like 4z to the third. So if I'm creating some polynomials that have these properties, if I want a degree 6 binomial, I need 2 terms, and then my term with the highest degree has to be degree 6. There's really an infinite number of options here. If I want a quadratic monomial, quadratic means it needs to be degree 2. Monomial means one single term, so let's do 7/3 x to the second. A trinomial that's quadratic and has a leading coefficient of 3 has to again be degree 2. And then leading coefficient means that degree 2 term has to have a coefficient of 3. So what I have right now actually won't work. I realized I didn't actually make it so it has a leading coefficient of 3, so that needs to be 3x squared. If I'm simplifying this expression involving polynomials, I'm just going to do my operations and combine like terms. So I need to multiply things together here before I can add my like terms. So if I multiply, I'm going to have to make sure that I add my exponents. Multiplying 3x squared times each of the terms inside is going to give me that result. And then if I find my like terms of 4x squared and negative 3x squared and combine them, that'll give me 1x squared. So 3x to the fourth plus 6x cubed plus 1x squared.